Hello everybody, and welcome to a day of geometry here in Math 7, and we'll be discussing today some triangles, some aspects of triangles. We're going to talk about what they're like, how we define them, some attributes of triangles, and then how to solve some problems with them. So get me out of the way, and here we go. When we talk about triangles, and you know what a triangle is, we've got a bunch of different kinds of triangles here. When we talk about triangles, that's an ugly triangle. Ugh. When we talk about triangles, we can talk about them in two ways. And one way we talk about them is by talking about their angles. And the angles of a triangle, when we're classifying them by angles, we can have what's called acute triangles, and that's where all of the angles, all of these angles right here, I've got three different angles. They're all less than 90 degrees. So that's one example. Here's another example where all the angles are less than 90. We talk about right triangles. And right triangles is where one of the angles, there's that box for the right angle. One of the angles is a right angle. One of them, so it might look like this. That might be the right angle right there. That's 90 degrees. Those are some examples of right angles. Or it could be an obtuse triangle where one of the angles, let's see, there's 90 degrees. One of the angles is bigger than 90. One of the angles is an obtuse angle. So either they're all acute, or one of the angles is right, or one of the angles is obtuse. So we talk about it, that way. Because what happens in angles, or in a triangle, and I could spend a lot of time if I wanted, you could look this up on the internet. This angle, and this angle right here, and this angle right here, they're three different angles. They all add up to, if I call this angle A and B and C, those three angles add up to 180. 180 degrees. And I could cut this out and put angle B next to angle A and cut out angle C and put it next to A. So, they look like this. Angle B is right there, and angle C are there. They form a straight line. They're 180 degrees. So that's why you can't have two right angles in a triangle. Both lines would be shooting straight up, and it wouldn't make a triangle. Same thing with obtuse. If two of the angles are more than 90, then that messes up the 180. So all the angles of a triangle always add up to 108. Just some ways to classify angles. So when we have that, if I've got a triangle that looks like this, and I tell you that this angle is 100, and I tell you that this angle is 30, you can figure out the angle of the measurement, the degree of that angle. It's because 100 plus 30 plus whatever this is, let's say it's angle C, plus C, all of that has to equal 180. And then it's just an equation you can solve. If I have one that looks like this one is 80 and this one is 50, we can figure out that one. We can figure out the angle X by just taking 80 plus 50 plus X is 180. And then to make it really difficult, if I told you that this one is, let's make this one 60, and let's say this one is X, this one is 2X. Whoa, it's a little more difficult, but it's just the same idea. 60 plus X plus 2X equals 180. Solving that equation is a little harder, but you've done it before. 60 plus, those are 3 X's, 1X plus 2. Is 180. Now it's just a two-step equation. Subtract 60 off, divide by 3, and with your calculator, I'm just saving you time on this video, X is 40. So that means this one is 40, and this one is 2 40s. So this one is 80. And then you can check your work and see if it actually does add up to 180. So just a couple thoughts on angles of a triangle. We also talk about angles when we talk about their sides, the sides of a triangle. we talk about equilateral triangle, and there's equal, lateral means sides. So there's equal sides, meaning all three sides are exactly the same. This side and that side and that side have the exact same lengths. Look like this, and trying to make them equal if they're doesn't look equal. Maybe if I draw it a little bit better, right there we go, not that. There's three equal sides, and it will always look this way. It creates it where all the angles are the same as well. But this side and this side and this side are all the same. Those are equilateral triangles. An isosceles triangle, so equilateral is they're all equal. An isosceles triangle is where two are equal. So three equal sides, two equal sides, it could look like this. This side is equal to that side. Or it might look like this. Or that side is equal to that side. I could spend a lot of time on this and tell you that basically if you take this vertex and you just kind of pull it up and down, the sides of the angle change, and then you can see that those two are the same. So you have equilateral, isosceles, or you have what's called scalene triangles, and that's where there's zero sides that are equal. This side is less than this side is less than this side. It'll always be something along these lines where it comes out a little bit there to make them just a little bit not the same. That's how we classify them with sides. Now, there's something about the sides of a triangle that we discuss, and it's called the triangle inequality theorem. And remembering the name of it maybe isn't as important as just knowing that if you have two sides of a triangle, say this is 10 and this is 3 and this is 5, you can pick a side. Let's pick this side. The other two sides, I have to actually make it 15 to show you what I'm talking about. The other, let's see, and I'm going to mess it up here. My goodness, I'm messing this whole thing up. I'm picking sides and I'm not getting it right, because this side right here, these two sides together have to be longer. I'm going to make it 8. Otherwise, I'm showing you how it doesn't work. With 10, are those two added together longer? Yes, because that's a straight line, so these have to add up to more than 10. So they do. Well, what about this one, 8? When I take 8, do these two add up to more than 8? Yes, they do. And then when I take 15, do these two add up to more than 15? Yes, they do, so it can be a triangle. If I can show you maybe this way. Let's say this is 12 and this is 5 and this is 6. See how these lengths, they don't even equal 12. They don't even reach each other. If I were to lay them down, 5 would get to about right here, and 6, if I lay it down, gets to about right there. They don't even make 12. They can't even reach each other. So that does not work. If I've got a triangle that looks like this, and let's say one is 15 and one is 30, this one right here has to be more than those two added together. So if that's 45, this one has to be, we'll say, if I were to say 40. But the way to make sure it works is, what about 15? Do those two added together, are they more than 15? Yes. And what if I take this one? When I add these together, are they more than 30? Yes, they are. So that checks out. That is a triangle. The two sides have to be longer than the other one. That's the triangle inequality theorem. So just a couple thoughts, just a couple items, just a couple ways that we classify triangles, and we look at them with sides and angles. Hope it was informative. Have a great and wonderful day.